Well, welcome everybody. Today we're going to continue our discussion on Chapter 12. Just as a review of due dates, please be aware that Tuesday are the due dates for the assignments. So just be aware of that. And we also are going to talk about problem 45 today. That's your 25-point problem. I'm going to give you some pointers on that as well as we go through our discussion here. So let's begin where we left off on Tuesday, and that was working on problem 33. Remember, we're doing the discounting models, the net present value, and also eventually the internal rate of return here. So we did A already, and we found that the net present value was positive. Being positive, we would accept this project. We are basically recovering the cost of the project, plus we're earning, in this case, 12% on the project as well, something above that 12% requirement. So we're going to practice this, and the second part of A here, it says, should the company, well, we already answered that, they would accept it, obviously. So I'm just going to move this down here. That just answers that question. Let's go to B. A different scenario here. Evie is interested in her own business, and the cost of the business was a $270,000 cost. So in year 0 here, we're going to spend $270,000, and her goal is, or her projection is, that she's going to get $52,500 per year for the next, hopefully, 6 years. In addition, in question 2, which is associated with letter B here, they expect, in number 2, in the required section, or she's expecting an 8% return on her investment of $270,000. So in this regard, it's an even cash flow. We get the same amount, $52,500, from years 1 through 6. $52,500. So which table do we use then, guys, to get that? Or what kind of payment is this when I get the same amount every year?
Annuity.
The annuity, right? Annuity. So Brianna, what then? Oh, Carla's here. Welcome, Carla. Brianna, what page do I go to in the book for the annuity numbers? Page 671, perfect. On the test, you will actually be given a table like 671 and also 670, so you can use those numbers to complete the exam. But for this case, we're going to page 671. Because it is an annuity that we receive the same amount multiple years, we got to, or should go to, the 8% column, row 6. So what factor am I, or discount factor, am I going to multiply by? $4.62288. 4.6288. That's perfect. And that equals how much money? Oh, I don't have my calculator.
242, 701.
I'll just go with the whole dollar amount. And obviously, we're not going to have enough, are we? We're going to be short here. 32,000. No, it's not 32. So my negative, the amount I spent, is more than I actually expect to receive in future cash flow. So the question then, obviously, this is my net present value, and net present values can be positive or negative. If it is negative, should we purchase the specialty shop? And the answer is no. So, no. Net present value is negative. So we certainly wouldn't then purchase that particular capital investment. And that's really the function of all of our models here, is to determine, do we invest in this capital investment or should we not? They changed the scenario in this particular problem. Instead of the 52,000, now she's expecting a higher cash flow, 135 versus the 52.5. So we lay the problem out the same way. We have year 0 with the investment of 270,000. We have the same cash flow period, years 1 through 6, but now we're going to use 135,000, and we're going to multiply by the discount factor, same one, 4.62288. And now at this point, how much do we get now? I'm assuming it's a bigger number, quite a much larger number. $624,089. So quite a bit more than the initial investment. So we have a positive number, how much?
354,089.
089. So over 354,000 net present value is positive. If it's positive, then we would proceed. So this is a nice function also. We did 2 different scenarios. So we now know, before we even begin this process of running this business, that the ability to generate 52,500 is not enough per year. 135 is way too much. You know, you have plenty. So at some range of sales or profit, we'll be in good shape. But if we get below that 52.5, we're not going to be in good shape at all. Our final process of using net present value here is, again, it's an algebraic equation. Using page 671, because we have an annuity here. We have a cash flow of 135 per year. We know the net present value is 63,900. So I'm going to lay this out again. So kind of going backwards, right, into our process. We know the net present value is 63,900. And that really is a function of an investment amount, which we don't know. We'll call that X. And that X is a negative number, right? That X is a negative number. Plus right? You can add to that our cash flows, again in parentheses. We've got 135,000 times the number on page 671. Well, I know that the discount factor is 10%, but we need to know for how long. What does problem C tell us for length of years? Page, I don't know, 8 years. Thank you, Sydney. So using the 8 years and 10%, what is the discount factor, the DF? Sydney, do you want to take it? Eight years. Page 671, the annuity table. 10%, Carl.
5.33493.
I think you said this, 5.33493?
Yes.
All right, I'm going to put a negative symbol in here because it's not showing up very clearly. Negative investment plus this cash flow. So, Brianna, what is the dollar amount here of, so I still don't know X, which is negative. What's the dollar amount of this function, 135 times 5.33493? How much are we looking at here? $720,216. Okay. Are we good with that number? Okay. So how do I get X by itself then?
So,
Yeah.
I say we can subtract this.
Yeah, we
one
would
too.
subtract both sides, right? To get X by itself, that comes up to 0. We would subtract this side of the equation, which will make this side negative, which is fine, because I have a negative X on the other side. So what's my negative over here? 6 something?
Negative 656,316. 300.
Whoops. 316. And obviously we divide by -1 to finish it out. Which makes this X, which makes this our investment. So our answer for problem, our third problem here, is the investment amount required to give us the $63,000 of net present value is $656,000 investment. So, like I said, this is a practice one, basically going backwards, using the equation, how do we get the net present value? It's our negative investment being offset by the positive cash flow that's coming in future years, discounted obviously to the present dollar amount. Any thoughts on that process or any questions here? Carla, Eric, you're all right out there? Brianna? Okay. All right, awesome, guys. Super. Thank you. So let's look at what else we have. Just some more information about net present value. We can change a lot of factors. We can change the discount rate. In other words, we can do a lot of scenarios with net present value. And that's what they're talking about here. We kind of talked about it with that individual who was looking to buy the business and finding out that just changing the cash flow amount, we went from 52.5 up to 135. We were able to make a net present value that was negative to a positive net present value. So that's what they're talking about here. Or instead of changing the cash flows, we could change the discount rates. We could change the length of time period. Also would have an influence on our net present value. So it's a good assessment of how risky we are putting ourselves in when we buy this piece of equipment. Also be aware, as our discount rate increases, right, it's harder and harder to meet our net present value positive number. So this is what I need you to know for the test. As the discount rate goes up, my net present value positive number will come down. So it's harder to make not only the return on the investment, but also make the return on what the company desires. So as the discount rate goes up, and that's what it's showing here, look at the net present value. It comes down as we make it higher and higher. All right. Again, that's that assessment of risk too that can be done. I'm going to skip here's how it's used. Our final model or measurement tool that we have available to, again, determine if an investment is worth our work and effort, and that's called the internal rate of return. And this discussion begins on page 656. You will need to know the definition for the test. It's when our project cash flows equal the present value. In other words, the internal rate of return will give us a net present value of 0. That's what you need to know for the exam. When the project's flows equals the cost of the project, or in other words, when the net present value is 0. And the goal is very similar to net present value. And this is just the formula for it. If the internal rate of return is greater than the required rate of return, we accept the project. So if the company's or the project's internal rate of return is greater than the company's desired rate of return, if that is true, then we accept the project. Obviously, if it's less than, and this is also on page 656, if the internal rate of return is less than the cost of capital, hurdle rate, desired rate of return, then we reject it. We reject the project. So know that for the test. Here too, like with our net present value. Oh, I do need you to know this. One more comment before I leave this. On page 656, because of the simplicity, because we're looking at one basic number, it's the most widely used of our capital investment techniques. So this is the most used. Let's just put that. Most used technique. The internal rate of return is the most widely used. Please know that for the exam. Like our net present value, cash flows can be even or uneven. So this computation is really easy when it's even. It becomes very hard, very difficult to determine when our cash flow is uneven. Not uniform is what they're talking about here. To help us, when the cash flow is not even, we're going to use our calculator to find the internal rate of return. We're not going to be guessing like some of the problems have us guess what the internal rate of return is. We're going to actually use our calculator instead. But if the cash flows are even, it's pretty easy. Example 4 here is one that shows us a cash flow that is even. So if you look at this formula, and this formula is on page 657, it's really easy. We have $50,000 a year, 6 years. So what type of cash flow is this? It's uniform, right? And we call this uniform cash flow an annuity. So here again, we're going to be using page 671 of our textbook to help us figure out what our internal rate of return is. In this case, the answer was 4.1, which is not the internal rate of return. What does DF mean? It's the discount factor. DF means discount factor. We're going to use this discount factor, 4.11, and we're going to go to row 6 on page 671, and what interest rate do we come up with? So I'm going to jump to 671. Carla, are you with us? What interest rate on row 6 has 4.1141 in it? Yeah, page 671 because it's an annuity, Carla. 4.11141. Row 6. What interest rate? 12. Awesome. Great job. That's it. That 12% is our internal rate of return. 12% is our internal rate of return. So you'll have to do that on the exam. And remember this formula. What's on top is the investment dollars. The investment dollars are on top. our cash flow per year in dollars is on the bottom. That gives us what? The DF, which is our discount factor. And then from there, we got to go to the annuity table to figure out what interest rate or internal rate of return was. The other, I think they use non-uniform also. No, they don't. They basically, you can do it non-uniform, but we're going to use our calculator for those. So let's try the internal rate of return computation here using exercise 34, page 684. Let's see. Okay, we have an investment cost of 7.2 million. What is the cash flow? We got cash revenues, cash expenses. So what is my net cash flow? It is even. Exercise 34 on page 684. What's our net cash flow?
Is it
2 million. And that 2 million is the amount I'm going to receive that's my profit basically every year for the next 5 years. So if I have an investment of 7.2 million, I'm expecting 2 million of, let me put that in red, 2 million per year for the next 5 years. What is my discount factor? It'd be 3 something, right?
3.6?
3.6? Good, excellent. I'm assuming somebody answered here. Excellent, Brianna, thank you. Eric, going to page 671, Eric, of our textbook, row 5, where does the 3.6 occur? What percent? I'm looking for the percent. 3.6. I think it's row 5, right?
Yeah.
What's the closest one to 3.6? Well, maybe, Eric, do you have your book? You might not have your book, huh? Oh, okay. I was just asking, well, Carla, what percent, since you were not there, Eric? 12, yeah. 12 is the closest to 3.6 using our table here. 12% is what I'm looking for. And that 12% is the internal rate of return. Now, before we answer the next question, let's just try our calculator and practice the internal rate of return. So if you have your calculator handy, it's really going to be useful on the test. Because again, you don't have to read a table, it gives you the answer right away. Remember, we're going to be on that second row here for cash flows. Second function, clear work, CF, net present value, internal rate of return. Those are the three buttons we're going to be using for the most part. So we're going to start with our cash flow here. CF0 means the actual investment. So we were looking at an investment of 7.2 million. I wish I could make this bigger, but it doesn't. So enter the 7.2 million as a negative number, and that's the key here. You'll get an error if you don't put that negative symbol in there. Once that number has been entered, hit the enter button where it's the top. It's by the set up on top here. And you should see a little arrow that appears once you hit the enter button. At that point, I want you to hit the down arrow, and it should say C01. What is the cash flow in year one, basically? And what did we say our cash flows were? Our net cash flow. So we hit the down arrow, we should see C01. Do you see C01, Sandy?
No, I think I did. I think I started out wrong. What did I have to hit first?
CF, the CF.
Let's see. Okay.
And then hit second function, clear work. Now enter the 7.2 million, negative, enter. There you go.
Okay.
Now down arrow. Now you're where I'm at. Okay? Everybody at home okay? Okay, thanks guys. All right, 2 million was the amount that we're going to receive. 2 million, so put that number in. That will obviously be a positive net cash flow. Positive cash flow. And as soon as I have that, hit the enter button. Again, you should see a little arrow that shows that it's been entered. It's right in the above the number here. Everybody see the arrow? Yeah? Now, that cash flow goes to letter F. I don't know why I don't use a Y, but years means F. And the years, how many years am I going to get that 2 million in a row?
5.
5. So instead of 1, let's put 5 here and enter that. We have no other cash flow, no other periods to worry about. So then just go to internal rate of return, the IRR button. Click on that. And then CPT, right where the quit is, CPT means compute. And you should get 12.054. Which is the exact number on our calculator. In most cases on the test, in your problems, I would recommend using your calculator. It's not too bad when the cash flows are even, but when the cash flows are not even, it's a mess. Okay? So, now that we know, let's do the net present value. Since we're doing this, we have our calculator all loaded. Click on the NPV, guys, the middle one. What does I mean? What is I?
Interest?
Interest. Yep, that one does correlate. If you look at the question, the required question number 1, what was Seneca's company's cost of capital? Problem 34, under required, number 1. Does everybody see the 16? Problem 34. That's what we're going to enter here, 16. So let's do that. And hit the enter button. Net present value needs the company's desired rate of return to compute. So we have to have that. We don't need it for internal rate of return, but we do need it for net present value. Click the down arrow button, and you should get NPV that pops up. Once you see the NPV, press compute, CPT. So I'm going to write that over here. What number did we get? What is our net present value? It's a negative, right? It's a negative $651,413. Did anybody not get that? Or know how we got to that point?
I got stuck after that.
That's fine.
Which is better.
So you have, did you get the internal rate?
Yeah, I got that.
Okay, then click on NPV. That's the I. So that's 16 then. Type that in and enter. There we go. Now compute. Perfect. Excellent. Guys, anybody else? Guys at home? All right. Do you guys have a financial calculator? Okay. Awesome. Eric, you do too? And you're okay with the calculator? How to use it? It'll make the test a lot easier to do. So let me know if you don't, or if you're having trouble. Okay, so going back to the problem, we've got 12% internal rate of return. We have a negative net present value. So should Seneca proceed with this capital investment of $7.2 million? And the answer is no. The answer is no. And I would like to also have you make these notes. The internal rate of return, which was the 12%, is less than the 16% company return. That's why it's a no. That's why it's a no. The internal rate of return, the most widely used, right, measurement, was less than the company's 16. We also found out that the net present value was negative. Both the net present value and the internal rate of return models will give you the same answer, to accept or reject. So if the internal rate of return is below the company's return, we reject it. If the net present value is negative, we reject it. The opposite is true, we would accept it on either way. You need to know that for the exam. All right, there's a couple of fun ones here. Let's just quickly go through those before we break. Kathy is the next one, letter B on problem 34. Her investment will save her, in this information system, will save her $240,000. She estimates that the system will last 10 years. The system will cost 1.248 million, and the company's cost of capital is 10%. So we have to compute our internal rate of return. We do have an even cash flow. So this time I want to use page 671 first, and then we'll do our calculator second. See how we come up with our answer here. The savings, 240,000. But we have to use that and divide it into our 1.248 million. This gives us our discount factor. So our discount factor is equal to 5 something?
Five
5.2? Using our book, we're going to use row 10. Why am I using row 10? 10 years. So the problem has to tell you how long this cash flow goes. So page 671, 10 years. Eric, are you ready? Where does our 5.2 land? What percentage? $5.2. Well, let's try. Carla, are you with us yet? Yeah, I think 14 is a good one. Yep, I agree. Eric, are you okay with that 14? Okay. The 14% is our internal rate of return. Let's try our calculator quick. It doesn't take long. So we bring up our calculator. Again, click on CF, second function, clear work. So we got a clean slate here. Cash flow in year 0 is the investment, 1.248 million. So enter that in. Make sure the negative goes in. Hit the enter key. Down arrow. What's CO1 again, guys? Cash flow in year 1, which would be what? How much am I getting, or how much am I saving? The 240. That's what belongs here. Yep. So enter the 240. And for how long? 10. So down arrow again. Time frame 10 years. So 1.248 million negative. Down arrow. Do you have it in?
Yeah.
You're, okay. Enter that and click on internal rate of return, guys, and compute. The calculator gave us what? 14.079 or 0.8. Yeah, depends on how many decimal places you're showing. So the calculator answer is for the internal rate of return, 14.079. CNOW's answers will always be to the whole percent. They're assuming you're using the tables, so just be aware of that. Calculator is much more accurate. Since we're at this point already, what's the net present value? What is the cost of capital for this problem? What was the company desired rate? The company was looking for 10%. On the surface, using internal rate of return, will we accept or reject? Accept, right? Our internal rate is 14. That's greater than our company of 10. So let me enter the 10. The net present value is going to be a positive 226,696. That's our net present value. So should they accept? And the answer is yes. We have the internal rate of return of 14% is greater than the 10% desired company return. And we also have a positive net present value. So the net means net, the cash flow is netted against the investment going out. Our final one is letter C. We have a cost of the building is $2.88 million as a 15-year life. The internal rate of return now is 25%. But I need the discount factor. That's what I really need. So let's go to the 25% column on page 671. I was hoping for a column. That's pretty high. 25%. Go down to row. So I'm on page 671. The 25% column. Row what? 15 gives me a discount factor equal to what, Allison? I don't even want to read that row.
3.85926
is equal to our investment, 2.88 million, over X. X is our annual net cash flow. That's what we're trying to solve. So we basically got to get X by itself. I can put X on this side. Is equal to 2.88 million. Oops, I forgot a 0. So how do I get X by itself? Divide, right? Divide this side by 3.85926. Divide this side by 3.85926. X is equal to 7 something.
746,257.
Oh, I got lots of answers this time. Rock on. Yep, they all agree. Thank you, Eric. 746,257. Brianna got the same answer. So this is the cash flow I'm receiving for the next 15 years in order to generate a internal rate of return of 25%. Pretty big number. And that wraps up problem 34. Any final thoughts on how this discount factor works in internal rate of return? That's what we really needed to get to. All right, let's stop here. Let's take our first break. We'll come back in a couple minutes. On page 661, oh, excuse me, how about 659? Please know these definitions. Page 659, actually 662. There's a post-audit. Remember, we're making a lot of assumptions. And it's always a good idea that years down the road, after you bought the equipment, after you looked at the benefits and costs, to see how close you were to your estimates. So that's what post-audit means, is to verify, hey, did we look at the right things when we thought about this project? Did we actually have a pretty good handle on what it would cost us and the benefits generated from this investment? So that's what post means after, right? After the investment is done, how good were our predictions? So know that. And then it talks about benefits and, again, costs with this post-audit. It's very expensive. The other term I want you to know or know about is this mutually exclusive project. Page 662, this is on. And we talked a little bit about this already when we looked at payback. It's two competing projects, right? And one is picked for the actual project that we're going to do. Remember, most small companies, which are not just small, but a lot of companies, we can't afford to do all the projects that we want to. So we have to pick one or the other. So when you have competing projects, the author, and I agree, feel that the net present value, and that's what it talks about here. Let me get to that point. Right here. In your book, please know the net present value, not the internal rate of return, should be used for competing mutually exclusive project analysis. Net present value should be used in that analysis. Example number 4, is it 4? 5, helps us show this effect. So in example 5, which is on page 663, we have project A here, or design A, and design B. Design A, $180,000 investment. We're going to get $60,000 a year for 5 years. Design B, our investment is $210,000, expecting $70,000 per year for 5 years. The company's cost of capital, 12%. On my next slide here, it shows the analysis. We have a positive net present value for design A. Great. That must mean what? The internal rate of return, which was 20, is greater than the company's was 10, right? I already forgot. How terrible. 12, thank you, Allison. 12%. So based on this, based on the net present value and the internal rate of return, we would accept project A, right? We would accept it. The book then goes into the analysis on B. Here's B, a little clearer. Here the net present value is positive at 42,000. The internal rate of return, again, is greater than the company's 12%. This one, too, we could accept. We can't accept both, so which of the two do we accept?
That one, B.
B, right? And the reason we take B, more money. Very good, Sandy. So with competing projects, we're going to use the net present value to do the decision for us, right? It's the largest net present value of the two, and that's why we would take this. The book or author talks about this one creates more wealth. More dollars for the company than the other one. The internal rate of return was the same for both. It didn't show us any different. It was 20% for both. But because of our analysis, because it's mutually exclusive, we will pick the largest net present value one. I gotta redo this. It's too messy. All right, good deal. So understand that for that multiple choice question, net present value is even though internal rate of return is the most commonly used, this is a small subset. Use net present value when you got competing projects. Okay. Let's try one. I think, do I have one here? Yes, problem 40, guys. Let's try this. We'll actually use our calculator for this one. I want to use the calculator for both net present value and internal rate of return. Let's bring up our calculator. Clear it out, please, guys. Hit on cash flow. Second function, clear work. We'll do project 1 first. Our investment was 100,000. It shows the cash flows. What's the interest rate, though? What's the company's desired?
10%.
Does everybody see the 10? The company percentage that they want to achieve on their investment is 10. So we need that for the net present value. All right, so how do we get this information in? And this really gets students on the test. So this is basically a test example. So we have 100,000. Don't forget the negative. Enter that. What was my cash flow? So down arrow. What was my cash flow in year 1? For project 1? 0. And you actually have to put that in your calculator. So put 0 in, please. And then enter. How many times did we have 0, guys? Just once. So down arrow, you should have F now on your calculator. 1's the default, 1 year. That's what we want. You can hit enter if you want to, it doesn't matter. But then down arrow for what's the next cash flow amount?
134.56.
Yeah, 134,560. Enter that in for your second cash flow, because it's different, right? Sandy, you okay?
Fill in on that one.
Okay. Oh, yeah, make that a 1. Click next. Yep. And then enter. Now down arrow. Cash flow 2 is where you got it. There you go. And enter, Sandy. Yep.
Yep.
And then down arrow again. How many times did I get the 134,560? Once. And that's what's the default. So we don't have to do anything there. Go over to the net present value button. What is I? The 10, right? Enter the 10 in. And then enter. Down arrow, you should get NPV. Does everybody have that? Once you hit the NPV, hit the compute. And my net present value for project 1 is 11,207, let's just say. Let's find the internal rate of return right away. How much? How do I do that?
Hit the IR.
Yep, just really easy. Just hit the IR or the next button, and then what, Sydney?
The computer.
The compute. And we get 16%. So would we accept project aid looking at the net present value internal rate of return? Yes, they give us the same answer, right? We have a positive number for net present value. We have this internal rate of return greater than the 10%. Both of these computations gives us the accept analysis, or answer, I guess you could say. Guys at home, that look good? I'm not moving too fast, I hope. If you got it, I'm assuming I'm not. Let me know, guys. Let's do project 2 right away. Again, go to cash flow, CF, second function, clear work, right? Same investment, 100,000, same cost of capital is 10. Cash flows are different. So let's put that back in. 100,000 again, negative. Enter. What's now my cash flow?
63857.
63857, Allison, very good. Make sure you hit the enter key. So cash flow 1 should be 63857. Hit the down arrow. How often do I receive that cash flow?
Twice.
2 times. So hit 2 for F1 and enter that. Is there any more cash flows, any different amounts? Nope, that's all we have. So we're done with our cash flow entry. Click on net present value. What is I? 10. Enter. And then down arrow. And compute. Net present value is positive at 10,826. 10,826. And the internal rate of return, Brianna, internal rate of return? Oh, okay. Carla, do you have the internal rate of return? 18%, really?
Yeah, well, 17.98.
17.98? Yeah, that's pretty close to 18. I agree. So they're both, this is positive, right? That's good. This is greater than the 10, so that's good. We certainly would accept this order as well. But which one of these two do I pick? And the test will have us do the same thing.
The second one. First one.
For actually, the first one.
More money.
More
Oh,
money.
this is the greater NPR.
Yes, that's what the author is talking about. This is the one we pick. We pick the greater of the two net present values. That more wealth would come from that first project than from this second project. That's what I want you to do for the test, right there. Now we've used our calculator, right? We used our calculator. You can use your book too, if you wish to figure out the internal rate of return, the net present value. So you can practice that on your own. All right, now I want to, in the last minutes here, talk about your project. Otherwise, I know I'm going to get a lot of emails. So let me get a seat here. If I could have you turn to the next page, our project is problem 45. It looks worse than what it really is. Now let me save what I got here. I have a separate slide for this. You guys don't have this yet, but it will be in my notes for today's class. Page 689. 689. All right. So we have this doctor looking at a new piece of equipment. The investment in the equipment is $74,000. So they're trying to decide, is it worth the $74,000? Am I going to make the money necessary to have the payback, right, to get that return to me plus my profit? I think the desired profit for this problem is 12%. So that's our goal. Can we make 12% on our investment here? All right, so the reason that this problem is messy is that the information's spread out. So if you read in the paragraph, we're hoping to save some costs, 50% by doing this using this new equipment. The equipment has an expected life of 4 years with a salvage value of $6,000. So underline that, the 4 years, 6,000 salvage value. You do need those numbers for the problem. It then shows that the cash revenue increases year 1, 2, 3, 4. After that, this is my first note. Each year, they're expected to have cash expenses of $3,000. So here's my first note. They're expected to spend $3,000 additional expenses every year, and this will reduce, right, the revenue for each year. So in year 1, what's my net cash flow then? Just for year 1. Yeah, 16,800, right? That's my expected cash flow in year 1. And you do that same process for years 2, 3, and 4. Okay. Comment number 2, the salvage value. And specifically, the accounting rate of return computation. The salvage value of $6,000 is only used to compute the expense. Remember, the depreciation expense is straight line. So we need that salvage value to compute the depreciation expense, right? It's not included in the cash revenue. So in year 4, I don't include that for the accounting rate of return. However, my next comment, for net present value computation and internal rate of return computation, it is. So in year 4, I'm going to take my 32,400. I'm going to subtract my 3,000, but I'm also going to get what? The salvage value in year 4. So please add that note. Now that's just for the net present value computation and the internal rate of return computation. On this particular problem, there is no working capital addition or return. There's no additional cost associated with getting the machine running. So that's just a side note on the bottom there. Okay, any thoughts? I have one more comment yet on this.
Do we,
Okay, go ahead.
for the 3,000, do we do that for just the NAV2 and the IR?
Yes. Yes, NPV and the IRR, you will have to subtract the 3,000. Correct. Remember, cash flow is always revenue minus expenses by net cash flow. Like with the accounting rate of return, it's revenue minus expenses also. It's our profit in that regard. But with the accounting rate of return, we have to subtract the depreciation expense. Right? That's why we're doing the salvage value in our expense for the accounting rate of return. Do I use depreciation expense and net present value or internal rate of return? And we don't. There's no depreciation expense. No depreciation. Because remember, depreciation expense is a non-cash expense. Has no effect on cash flow. Net present value, internal rate of return are cash flow problems. So on the test, I trick some students. I give you this depreciation expense amount in a net present value computation. Why am I doing that?
See if I can dungeon.
To see if you use it, and you don't. So don't get tricked. The depreciation expense is only used here on the accounting rate of return. It's the only model that uses it. Payback does not use depreciation expense. Net present value does not use it. Internal rate of return does not use depreciation expense. That is critical that you know that. All right. Guys, please, on the bottom of page 689, read item 4, requirement 4, please. Take a few minutes here, read problem or item 4. And it actually goes to the next page, 690, a little bit. I'm going to go to the problem. I'm going to go to the problem in Cengage. It's a lot of words for one thing. You only need one number out of item 4. What's the number? One-third. Very good. Excellent. You only need that one-third item, right? All right. So I have shown here. Let me make this bigger. Here's the problem in C now, exactly like it's in the book. Requirement number 1, compute the payback. Round your answer to 2 places, right? Requirement number 2, accounting rate of return. Round your percent to 2 places. Does everybody know what that means?
Be 2 whole numbers and then 2 after.
2 after. Very good, Allison. Excellent. Number 3, net present value as a whole dollar amount. And then the internal rate of return should be just a whole percent. A whole percent. Even if your calculator gives you some other percent, CNOW is looking for a whole percent. That's why they're not talking about decimal locations on requirement 3. I'll give you that. Should they purchase it? You have 3 checks, so I'm just saying. Now, item 4. It's only 1 box. It's only worth a couple points. Some students just give up and say, I'm done in 2 weeks anyway. Why get it right? But I want you to get it right. Okay? It doesn't take that much more effort. So, Sydney, you said it was the 1/3 was what we need to look at, right? So basically what they're saying in problem 4 is, hey, our expectations are too good. We're not going to save or make as much as we thought, right? So what I need you to do for part 4, Sandy already said, Well, let me turn it to a different color here. Can you see this, guys? Remember, we subtract. 4 is net present value again. So then I'm down to here. And then Sydney said, well, let's subtract off 1/3 of that number. But what's a better way to do it instead of subtracting by 1/3? Because then I got to take that answer and subtract it from the 16.8. What's a quicker way? Instead of subtracting by 1/3. Yes. 2/3. That's what I want you to do. That's all that changes from requirement 3 to requirement 4 is the cash flow is being reduced by 1/3. So we simply multiply by 2/3 for years 1, 2, 3, and 4. But remember with year 4, I have that salvage value, right? However, that is not reduced by 1/3. The salvage value is not reduced by 1/3 in year 4.
So year 4, we still just minus the 3,000 times it by the 2/3,
Yep, and then what?
add the 600?
Then add the 6,000 on the end. Yep, because it's not influenced by the 1/3 reduction. Very good, Allison. Excellent. That's what I need you guys to do for problem 4, right? This is just for the requirement number 4. This is not a long problem, guys. So that's why I would really, really like it if you got this correct. This is requirement 4 only, not the requirement 3 numbers. I'm going to take a screenshot of this so that it's in our notes for today, okay? So that it reminds ourselves, hey, requirement 4 is a little different than normal. And requirement 4, guys, let me just clear the ink here now. It's just computing the net present value, right? And I'm not sure which direction they should do it. If it's positive, obviously it would be to buy it. If it's negative, then we should not buy the equipment, right? And that's the goal with this analysis. That's the beauty of this, these formulas, all 4 really. It really gives us a great way to evaluate whether we should invest in this project or not. All right, guys, any final questions? Like I said, I'll have this on our notes for today. I do have a pretest that we will cover on Tuesday. It's already in your packet. I also may do one longer problem also on Tuesday. So it will be a review day. And then our test will be opened at that point. You can take it after Tuesday, your test. And Thursday, you will be here next week Thursday, a week from today, if you wish to take the exam here in the classroom. But again, it's up to you which or when you want to do it and where you want to do it. I'm just asking for your honesty that you're doing it by yourselves. All right, gang. Any other thoughts, questions? Oh, thanks, Carla, for the 2/3. You're awesome. That's it for today, guys. Any final questions? Nope. Awesome. Have a great weekend.